Hi, my name is Qingdong Gong, and today I'm explaining what a pooling layer is in a convolution neural network. We will see the operation step by step, compare max pooling with average pooling, calculate the output size, discuss both the benefits and the information that pooling removes. The central idea is that pooling summarized a small neighborhood of a feature map, reducing spatial resolution while keeping the numbers of channels unchanged. And let's move on. Pooling normally appears after a convolution and nonlinear activation. A convolution produces feature maps. Each channel responds to some learned pattern at many spatial positions. The pooling layer then process each channel independently. It reduces height and width, but does not mix channels. In this example, a 28 by 28 feature map becomes 14 by 14, while the 64 channels remain 64. Pooling is therefore a spatial downsampling operation, not a learned feature detector. A pooling layer uses a window, also called a kernel, and moves it across the feature map. Use a stride at every position. It replaces all value inside the window with one summary value. With a 2 by 2 window and stride 2. The windows do not overlap, and each 2 by 2 region produce one output. The exact same operation is applied separately to every channel. Unlike convolution, ordinary max or average pooling has no learned widgets and no bias parameters. Let us compute maxed pooling by hand. We divided this 4 by 4 feature map into 4 non-overlapping 2 by 2 windows. In the top left window, the value are 1, 3, 4, and 6. So the maximum is 6. The top right window gives 2. The bottom left gives 5, and the bottom right gives 8. The output is therefore a 2 by 2 feature map containing 6, 2, 5, and 8. Max pooling keeps the strongest activation in each local neighborhood. Average pooling uses the same sliding window geometry, but computes that arithmetic mean instead of the maximum. For the top left window, 1 plus 3 plus 4 plus 6 equals 14. Yeah, and 14 divided by 4 is 3.5. The 4 output value are 3.5, 1.25, 2.5, and 4.5. Yeah, and max pooling asks whether a strong feature exists somewhere in the window Average pooling asks how much activation exists across the window, and the best interruption depends on the representation and the task. Yeah. Let's move on. And now you can see is 26, yeah, 26 and 13, 14, yeah. The output size follows the same sliding window geometry used in convolution. For one spectacle domain, the output is floor of input plus 2 times pending minus kernel size, dividing by stride plus 1, and with input 28, kernel 2, and stride 2, and no pattern. So the result is 14. Applying that to height and width changes, 28 by 28 by 64 64 into 14 by 14 by 64. The number of activation values falls by a factor of 4. This reduces memory and the work required by later layers. Again, the pooling layers itself as zero transposable parameters. Let's move on. Why is useful? Yeah. First, small feature maps reduce memory and computation in all later layers. Second, later units cover a large portion of the original image, so the effective receptive field grows faster. Third, max pooling can make representation less sensitive to small local shifts. In the strongest activation moves slightly, but remains inside the same window. The pooled value stays the same. This is a limited local tolerance, not a complete transaction invariance. Crossing a window boundary can still change the output abruptly. Pooling also removes information. It discards the exact position of a represent inside each window, and repeated downsampling can erase small objects, boundaries of the or fine spatial details. The matters for tasks such as segments and key point localization. Modern CNs therefore use polling selectively. A third convolution can learn how to downsample instead of using a fixed maximum or average. Global average pooling is a different operation. It averages every spatial location in each channel and produce one number per channel, often near the end of a classifier. It should not be confused with ordinary local pooling. To summarize, a polling layer slide a fixed window and over each feature mapped channel and replaces each neighborhood with a summarize. Maxed polling keeps the strongest activation, while average polling keeps the mean kernel size. Stride and padding determine the output geometry. Pooling reduces height and width. preserve the channel count and has no trainable parameters. Its benefits are all lower computation, faster receptive field growth, and some tolerance to small local shift. It costs a lot spectacle details that trade-off is the main reason pooling is useful, and also why modern architectures sometimes replace it with learned downsampling. And thank you. That's all my slides.